morning children, and welcome back to your chemistry class. So in the previous video we had studied about the properties of alkali elements, and today we are going to talk about some important compounds of that alkali element. So basically you have the compounds of sodium that is in your syllabus, that is to be studied. NaCl, sodium chloride. The most abundant source of sodium chloride is what? Seawater, and this contains the seawater. It contains about 2.7 to 2.9% by mass of this particular salt, right? And it is used as a common salt that we eat daily, or we can also call it as a table salt for the domestic purpose. And this is used for the preparation of even forming sodium peroxide. We can also form sodium hydroxide. We can also form sodium carbonate from NaCl, right? So let us begin with the first compound, that is called as sodium hydroxide. Sodium hydroxide, which is also called as caustic soda. Okay, soda means sodium, and caustic is always hydroxide. So sodium hydroxide. Now how is this prepared? Commercially, it is prepared by the process of electrolysis of NaCl, right? Where in the Kastner-Kellner cell, right? So a brine solution is electrolyzed using a mercury cathode, and a carbon anode is used over here. So the metal atom is discharged where? At cathode, and that combines with the mercury and forms a sodium amalgam over there. And chlorine gas, it gets evolved at the anode. So what do we see of the brine solution? I hope you understand what is a brine solution. When NaCl is added to water, it is called as a brine solution. So what are the cations and anions over there? Sodium ions are there, chloride ions are there, hydrogen and hydroxyl ions are there. So what reaction are we going to observe at cathode and at anode, right? So at cathode, what will happen? Sodium ions are going to move, they will accept electrons, and this cathode, since it is made up of mercury, so it is going to form sodium, and since it combines with the mercury, so it is going to form sodium amalgam. Clear? Now what will happen at anode? The chlorine ions are present over here, and they are going to lose electrons and form chlorine gas, which will be evolved at anode. A greenish yellow gas will be seen at anode. So the amalgam, now this we are talking about the sodium amalgam, which is when treated, this sodium amalgam when treated with water, right? When it is treated with water, so 2 molecules of water and 2 molecules of sodium amalgam, when they are treated with water, they give sodium hydroxide, NaOH, and hydrogen gas is also released, right? So we get this, and now when it reacts with water, sodium hydroxide will be formed, hydrogen gas will be given out. So what are you left out with? You're also left out with mercury. The amalgam is made due to mercury, no? So mercury is left back, right? Now what are the different uses of NaOH? It is used in the manufacture of soap, right? Manufacture of soap, also your paper, or even your artificial silk. So these are some of the things. Then petroleum refining, it is used. Then in the purification of bauxite, it is used. Okay, let me write down. In the petroleum refining, then it is also used for the purification of bauxite, right? Then it is used in the textile industries, used in textile industries, right? Then for the preparation of pure fat and oil it is used in the laboratory as an agent, and so on. So these were some important reactions of sodium hydroxide, also called as caustic soda. We now move to the next compound. Now let's talk about sodium carbonate, that is Na2CO3.10H2O. What is this called as? Sodium carbonate, or also termed as washing soda, right? So in general they are prepared by the Solvay process, right? So how do we go about with the Solvay process? The concentrate solution of the brine solution, that is the concentrate solution of the sodium chloride, it is saturated firstly with ammonia and then carbon dioxide is passed through it. Okay, firstly it is concentrated with ammonia and then we pass carbon dioxide through it. So it first forms ammonium bicarbonate, right? Further, this ammonium bicarbonate, when treated with your brine solution, it is going to form the PPT, forming NaHCO3, that is your sodium bicarbonate plus NH4Cl, right? Now the precipitates of this NaHCO3, they are separated out, while NH4Cl that remains in the solution, right? Now the PPT, this is heated and this will now give us Na2CO3. So 2NaHCO3, when it is heated, as I said, it is going to give you sodium carbonate. It's a carbonate, so carbon dioxide is also going to form and water will be given out, right? Now what about NH4Cl on heating with calcium hydroxide, right? NH4Cl when treated with calcium hydroxide, it gives ammonia and this can be removed in this process. So on heating it gives us calcium chloride plus water plus ammonia is given out, right? So this method cannot be applied for the manufacture of potassium carbonate, right? Why so? Because of its high solubility of potassium bicarbonate. Okay. Now what are the uses of this sodium bicarbonate or the washing soda? You know, it is used in water softening, in water softening, right? In the manufacture of glass or soap, in manufacture of glass or soap, or even borax and maybe caustic soda and caustic soda, right? It is also used in the papers, in the paints and textile industries. In textile industries, in paper industries, in the paint industry and so on, right? And you also know that it is used as a laboratory reagent. So this was all about your washing soda or sodium carbonate, that is sodium thiosulfate. Sodium thiosulfate, which is also called as hypo, okay, which is also called as hypo. What is the formula of this? The formula of this is Na2S2O3.5H2O. This is called as HYPO or sodium thiosulfate. So it is a salt of thiosulfuric acid. What is thiosulfuric acid? Thiosulfuric acid is H2S2O3. So your sodium thiosulfate, it is the salt of thiosulfuric acid. Now how is it prepared? It is prepared by boiling your sodium sulfite with sulfur powder. So let's see this, Na2SO3 sodium sulfite with sulfur powder, and we obtain Na2S2O3. What is this? Your sodium thiosulfate, right? So the excess of sulfur, it is distilled off and the filtrate is concentrated to get the crystals of hypo, right? Now let us see, it is a white crystalline solid, right? And its melting point is 320 Kelvin. At 490 Kelvin it becomes anhydrous, okay? At 490 Kelvin it becomes anhydrous or powdery form. It is highly soluble in water also, okay? Let's look at some of the reaction, like for example, how does it react with the dilute minerals. So with dilute mineral acid, for example, let's take Na2S2O3 and treat it with HCl. So what are we going to get? We will get NaCl, you have already studied this reaction before, plus SO2 plus sulfur. The yellow deposit of PPT of sulfur can be obtained over here, okay? Now with sodium nitrate, Na2S2O3 plus 2AgNO3, what it is going to give us? It will give us Ag2S2O3 plus 2NaNO3, right? And this AgS2O3 when diluted with water, it is going to give us the black PPT of, this is your black PPT, okay, of silver sulfide plus H2SO4. Followed. Then another reaction with iodine. So your sodium thiosulfate when treated with iodine, it is going to give us sodium tetrathionate, that is Na2S4O6. What is this called as? Sodium tetrathionate, plus it is going to give us sodium iodide, 2 molecules of sodium iodide. Now the reaction, it is used in volumetric estimation of iodine, and they are also used to remove the stains of iodine, right? Then what are the uses of this? Let's understand the uses over here. The hypo, it is used in photography, okay? Then it is used as an anti-chlor in the textile industry, as anti-chlor in the textile industry. Then it, as I just now told you, in volumetric analysis, okay, in volumetric analysis also it can be used, and also as a preservative for some fruit products. It is also used as a preservative of fruit products. Clear? So this was all about the different compounds of your alkali metals. Mainly the compounds of sodium is in your syllabus. So these are the 3 compounds that are in your syllabus which I have completed today. Now in the next video I shall start with group 2 or the alkaline earth metals, discussing all about the atomic and physical properties first in one video, and another video again talking about some important compounds. So thank you for today.